We're going to do this question where we're going to take in two dictionaries and return a dictionary which is comprised of the common keys and whose values are the sums of the lists that the keys map to in the previous dictionaries. It's so great when I don't screw up the recording and do it perfectly every time. Code Wednesday. So there's some things I need to import here from typing. Import. I need lists. I need dictionaries. So I want to do, I'm just going to grab this. Actually, I'm going to grab the whole thing. See if, oh no, grabbing the whole thing. Okay, we'll grab the whole thing. I just need to change these. And I need to change these. Okay, I'm just going to delete this here. So we just have to focus on this case, right? So we have two dictionaries. I'm just going to rename these to the things that I like. I'm just so used to having H's here. Okay, so first thing we need to do, well, there's many ways of doing this, so maybe I'll just do it this way. So first thing I want to do is find, no, maybe I'll do it like this. So for key 1 in H1, so I'm looking at a key in H1. If key 1 is in H2, that means the key is in both of the dictionaries, which means I should append to some answer dictionary the sum of H1, go away, H1 at key 1 plus the sum of H2 at key 1. I probably should declare this as a dictionary, and then I should be safe to return this. So everyone see how does this work? I look at all the keys of the first dictionary. I ask if that key is in the second dictionary. If that is the case, then key is in both dictionaries. And in that case, I say, okay, make me a new entry in my answer dictionary and put in the sum of those lists. So let's see if this works. What? EOL. Whoops, 4. Yep, it should be 3. Great. What was this called? Combine. Oh, I need these dictionaries too. Okay, let's just grab this. So combine does not work because this should be key 1. You guys can't see that. Doing really great today. Yeah. Okay, perfect. Let's try putting a 1 here, and maybe a -2, which means there should put a 0. Great, okay. So this was the first attempt. This is the one that you should do, right? The most basic, right? So I'm going to do another one, which is less basic. I'm going to use some list comprehension. I want to make it, again, list comprehension is not something that you need to know. It was something I was discouraged to teach you. But it's something that I think is so important that you should know about it, at least know about it. But you don't need to know how to use it. You don't need to know how to read them. So they're not going to be on your midterms. And I'm like 90% confident they're not going to be on your exam. And so when I use a list comprehension, that is bonus material. This is me showing you how to do something in an alternative, more Pythonic way. So from now on, if I use a list comprehension, remind me to also do the non-list comprehension way. I'll show you both, and I think that's going to be a good balance, but it is not testable. So I want to do this with the list comprehension one. So I want to basically create, find the intersection of keys. So shared keys I can make with the list comprehension. So that's a key 1 in H1. Key 1 for H1. Key 1 for key 1 in H1 if key 1 is in H2 as well. Right, so this is saying take all the keys which are from both dictionaries. Right, so this should create an intersection of keys. So let's just return this just to see that it's working. So this shouldn't return the answer. This should now return, a list of shared keys. Great. So now that we have a list of the shared keys, then I can just write a simple loop for key in the shared keys. I need some new answer dictionary. For key in the shared keys, h of answer at key gets sum of h1 at key plus sum of h2 at key. And now I could just return the answer. So let's see if this guy works. Great, that works as well. Okay, so there's two ways of doing it. I say in this one both are fairly equivalent. This is actually a tad better, the second one. It's a little bit more efficient. Because this one required 2 loops. This one only required 1 loop. Any questions about that? So sort of getting a feel of how to work with dictionaries and why they're useful. Write a function. Okay, so basically, I can't find the data that's supposed to be associated with this function. So let's just use the bands data from the other week. Where was that bands data? Here. So let's just combine what we've learned about files with what we've learned about dictionaries. So let's just convert this file into a dictionary. Let's say file to dictionary. And we're going to take, I need to import another type, text.io. So I want to take some file pointer, which is a text.io, and I want to return a dictionary. Make a file and convert it to a dictionary. Okay, so if we're given a file, remember that we can walk line through line this file. And what does the file look like again? Well, it's lines separated. It's lines whose elements are separated by commas. So I can do something like take this line and split it across the commas. Let's just look at this actually. Return 0, and let's just print this line. It's a good idea to run your code before it's finished, just to see that everything is working as expected. File to dictionary. I have to give it a file probably. How do I open a file? Fopen? Oh, is it fopen or just open? Open bands.txt for reading. And I give file to dictionary. I'm going to give it this file. And all this should do is print out the individual lines of this file. Great. And as you see, I have already separated them into the individual components. So notice that the second component and the third component should be cast to integers. So let's do that now. So actually the thing, line of 1 was actually the band name. What was line of 2? I think that was the rating of the band, which I will say is the integer casting of line 2. And then it was the number of plays that that band had, which is the, oops. Guys, you should have caught me. 0 indexing. Let's just give this a print just so I can show you that I found everything. So print band, go away. Band name, rating, and number of plays. So let's see what that does. Oops, I need to define a file. Number of plays is not defined. Number of plays. File the dictionary. Great, right? So I've managed to pull the information from the file, isolate the parts of the line, and now I'm just going to throw those lines into a dictionary. So here's my answer dictionary. Let's now say h at answer at band name, and let's just say that's equal to the rating and the number of plays. And let's just return this answer. Okay, so there's my file. I'm going to change my file to a dictionary. There it is. So for key in h, just print key, h of key. There you go. There's the data now, which is stored in a dictionary, so we can process it. Right? So you can somehow see how like moving the contents of a file into a dictionary would make the information in that file a lot more manageable. There's a lot of automatic libraries that will do this for you, but you should learn how to write some file processing. It's good to know how it's done. What is this? Port is head. Anyone heard of that? Never heard of that band in my life. Should put new bands in there, better bands. Just Drake over and over and over again, right? Reverse lookup. So suppose I give you, well, I can phrase it like this. Suppose I give you the phone book, and I now want you to tell me whose name corresponds to a phone number. That would be a reverse lookup. Now, it's a little bit different that it's a dictionary because phone numbers are unique. So here's a new dictionary where the items aren't necessarily unique. So suppose I have a dictionary which takes the integer 1 to Paul, 19 to Verbeek, and minus 31 to Paul, and I ask you to do a reverse lookup on Paul, you should return 1 and minus 31. Right? Return all keys that map you to the value Paul. And want to do a reverse lookup on the same dictionary, but look up my sister's name, Irene, it's going to return nothing because it's not in the dictionary. So let's now write a function to do reverse lookup. Brah. Oh, I hate these and these. I'm also going to have to change all of these. Right. And one more. Now I have the right quotes. Okay, so reverse lookup. So my answer has to be a list, so I'm just going to make that a list, and then I'm going to return that answer. So how do I build this? So I need to look, shouldn't be item, that should be value. So given H a dictionary and a value, find all the items that are associated with that value. That shouldn't be too hard. So for a key in this dictionary, if H at the key, so if the value associated with that key is the value that we're searching for, then I should just append this key to my answer. It's actually a fairly straightforward piece of code. Okay, let's see. Reverse lookup. Let's try it. Great. Yep, it found me. Let's try to reverse lookup Verbeek. That should give me a 19. 19, perfect. Okay. Maybe let's extend this. So instead of just doing a reverse lookup, let's return a dictionary, which will just do all of the reverse lookups for you, right? So instead of returning a list, let's return a dictionary. So suppose our input dictionary was taking integers and strings, right? So our return dictionary, whenever you invert a dictionary, one of the things has to become a list, right? So if I have a dictionary that takes integers to strings, the inverse dictionary takes strings to list of integers. Right? Does that make sense? Because it's sort of like we're inverting a function, right? It may not be injective anymore. And that should be this. Okay, so I'm just going to wipe this. And let's now say our answer is a dictionary now. And I want to return this eventually. So I want to build the reverse lookup. So first I need, so what I need is a smarter professor to teach you. What do I need? Okay, so I guess I just have to look through the keys of H. So for a key in H, then I get its value, which is what? H of key. I don't need this anymore because I'm just going to invert everything. So I get a value, and then I need to put that value in my dictionary. Whoops. And what do I need to do? I need to append the key. Okay. Why won't this work? So it will almost work. It's a good midterm question, right? Tell me what the error is and tell me what has to be corrected. Just walk through it line by line. Right, suppose you find a key in H. One of the keys is 1. So the first value that we should find is Paul. And then we're saying H answer at Paul gets appended that key. Yeah. Yes, yes. Okay, watch. Okay, so I can make a new dictionary, right? And I can give it new values. But what I can't do is append to this. Why? Well, because h of 2 doesn't exist. If h of 2 is made to be an empty list, then I can append to h of 2. Okay? There's no list stored in h of value yet. Does everyone see that? I can't append to it. It's not a list. So first I have to make it a list. But I should only initialize its value once. So I'm going to say this. If it's not the case that this key is in the answer already, then I have to initialize answer to something. And I'm just going to initialize it to the singleton list key. Else I can do this. And so now, the first time I want to store an answer, I'm going to initialize it. And the second time I go to that same key in h of answer, I'm going to append. Right? So something like this is very typical in dictionaries, right? If my key doesn't exist, then initialize that position, else manipulate that position. So let's see if this will work. Type is not subscriptable. Where did I do a subscript? Oh. Wrong list. Reverse lookup, reverse lookup, reverse lookup. So before we hit enter, we should agree what we should be looking at. So I should get a dictionary back with 2 keys, Paul and Verbic, and Paul should map to 1 minus 31, and Verbic should map to 19. Error. That's exactly what I wanted. Oh, I shouldn't have given 2. I need to take this away. That's not what I was expecting in the least. What on earth has happened? I'm going to try to reload that. That doesn't make any sense. Okay, people, help me debug. Oh, I see. I did index into this. That will help things. Okay. Nope, still wrong. Damn it. If not key in H answer, else. Can anyone see my mistake? I ask earnestly, because I can't see my mistake. Well, it goes through 1, 19, and minus 31. It's just failing to... Should this be key or value? I think I've swapped something. Aha. That's it. Okay, now I fixed it. Sorry. Great. Okay, so what I've done here is I'm saying walk the keys of the input dictionary. So in that case, it's going to be a 1, a 19, a minus 31. And grab the value associated with that key. So if it's key 1, then the first value is going to be Paul. I'm asking if Paul is not a value, if Paul is not a key in h of answer, then I need to initialize h of answer at that value and set it to a key. Remember, we're swapping keys and values here. That's why it's getting a little bit confusing. Else you can just put it in there since it's instantiated. Anyway, so this is working. You can study it a bit. How much time do I got? 20 minutes. So we've done this inversion. We're going fast today. Okay, so I'm supposed to go through this birthday example with you. Is there any questions? Just to waste some time. Can always tell you my trick-or-treat story now. You want a 5-minute trick-or-treating story? All right. So does anyone plan on going trick-or-treating tonight?
We don't have time. Sir, the stealing bowls of candy count?
That certainly falls into the category of trick, but these are all not interesting stories. My story is interesting. So, when I was a young, fatter undergraduate at McMaster, we were all starving and we're all poor. And we're like, well, it's Halloween. Today's a day where people will be giving away free candy if we just bother to walk up to the door and ask for it. But Paul, we're university students. Who is going to give us candy? Well, maybe 1 in 4 people will give us candy. And if I can get a 25% success rate, I'm willing to go with that. Right? So me and a few of my friends went out into the community, not dressed in a uniform, in any type of costume, basically asking people for candy as like 19-year-olds, expecting nothing. So we rock up to all of the doors, expecting no candy, but this is what happens. People are elated, excited to see us. Are you guys from McMaster? Yes. Oh, take triple the amount of candy. Here, take a ton of candy. And we're all like, okay. So like our bags really got full quite rapidly because we were getting candy from everyone and we were getting more candy than normal from everyone. So a few days pass, I'm in my dormitory eating my candy, and one of our friends comes in, and she's like, where did you get all that candy? And we're like, I said, well, we went trick-or-treating. Like, I earned this candy. She looks at me, she's like, Paul, you were supposed to hand that over to the sick kids hospital. So what, unbeknownst to me, there is a tradition of McMaster students going out and trick-or-treating for sick kids in order to hand the candy over to the cancerous children, basically. Which explains why people were giving us extra candy, because they thought it was going to sick children. So that's a story about how I stole candy from terminally ill children on Halloween. I feel a deep shame from that, but I also feel full of candy, so it's about even. Yeah, true story. I stole candy from sick kids hospital. Yeah. Any questions regarding that? Or about? Huh? I think I continued eating while I found out about this. It's like, well, the sick kids don't need this candy. They'll be dead soon. Okay. Too dank. Too dank. I know I can't put this shit on YouTube now, right? Okay. I don't know if I'm ever going to recover from this, but let's just look at this birthday example. Maybe that can cheer us up.
What if one of those children had diabetes?
Yeah, I might have saved someone from diabetes. Anyways, let's take a look at this example and try to forget about the fact that your professor is a deeply horrible human being. How do I get rid of these sidebars? Okay, so this is a very wordy description of a problem that was actually on the fall 2009 exam. Right, so certainly a question like this would be fair game on an exam because it was on an exam. So let's just take a look at what this dictionary looks like. I'm just going to copy it into my terminal here. So what do I got? So I have these. Let's look at the key value pairings. Key, h of key. So it's telling you that in February, there were birthdays. And on the 13th, Catherine had a birthday. This tells you that in May, there were birthdays on the 3rd and on the 8th. And on the 8th, there are 2 birthdays, right? One for Peter and one for Ed. Right? So we have a dictionary of dictionaries here, right? So the type of H is a dictionary, and the type of H at one of its keys is also a dictionary. Right? So we can say something like, who had a birthday? Who had birthdays in May on the 8th? Peter and Ed. Right? So that's how these dictionaries can get fairly useful when you can do multiple indexes on them. Now, the question that was given on your exam, on the exam for these students in 2009 was the following. Define a term called coverage. And the coverage is going to be the number of days that a month has birthdays. So for February, there is one birthday in February. The 13th is the only day with birthdays, so its coverage is 1. In May, there are birthdays on the 3rd and on the 8th, so its coverage is 2. Right? We don't care about the number of people with birthdays. We care about the number of days where there are people with birthdays. Okay, so the question asked here is, return the month with the largest coverage. Now, how could we do this? Should treat this like it is an exam question, right? You can't blank, right? This is already something that we would ask you on an exam. So you should think about this a bit, right? So how can we calculate the coverage of a month? Any ideas? All right, so we'll look at the dictionary. So here's H of May. What's its coverage? It also happens to be its length. Right, so the length of a dictionary is the number of keys, or the number of items, which are the key value pairs, right? The length of this dictionary is not 3, right, despite there being 3 list elements, right? So if I can get the coverage by looking at the length of H of key, so how can I find the month with the largest coverage? Yeah, this is just a simple, you just walk through the loop and find the one which is the largest. So let's just do that. Definition coverage. This is going to take a dictionary, which is complicated. So what was this a dictionary of? This is a dictionary that took strings to dictionaries that took strings to list of integers. And this should return a string. I don't care about the doc. Did they give us an example? Where's the birthday example? Yes, they did. So if I put this in, the coverage of this should be May, yeah? Okay. So the current maximum coverage, I need to give a default value. Yes?
For the dictionary, within the dictionary, isn't it the integer and then a list of names?
You are correct. This is backwards. Is that better? Yeah, the first dictionary takes a month to a dictionary, and the inner dictionary takes integers to lists of names. So thank you for that. The current maximum coverage has to be equal to some default value. I'm going to leave that there for the time being, right? Because this confused some people on Piazza. So next thing I'm going to do is and I also need an answer, which I'm not going to define yet. So let's just walk the keys of this dictionary for key in H. If the length of the H at key is greater than the current maximum coverage, then the current maximum coverage is the length of H of key. And the answer, oh my god, and the answer we should return is what? We need the key itself, right? The key is the month. Right? So I can be more explicit about this. For month in H, if you prefer, if length of H at month, answer is month. Okay, then I return the month. Okay, so regarding this default value, we do this a lot, right? Where we set some variable in order to compare it with everything in a list to find the smallest version of something. So the first comparison is always important, right? So I want to set current maximum coverage to a value so that this if statement definitely triggers in its first loop. Okay, so sometimes, well, I usually just say minus float imp. Right? It's the smallest integer. This is going to work in every single case, but maybe this is confusing. Notice here that the coverage is, what's the smallest legal possible coverage? 0. So if I set this to -1, this also ensures that on the first iteration, current max coverage will at least get set to 0, right? So in this case, -1 is like -infinity, right? I'm always just looking for like the first number that is the smaller than the smallest thing that I'm searching for, right? So -1 would work here, -100 would work here. 0 wouldn't work, right? If I set this equal to 0 and had a dictionary where no birthdays were, this would fail, right? Because it wouldn't, month would never get set. You should try playing with that in the lab. Okay, what was the next question on this? Next question. I should return answer. Maybe I should test this since I was so confident in it.
We also don't initialize the value.
Answer doesn't need an initial value because I'm not doing.
What?
Well, I'm only assigning it. I'm not operating on it, so it doesn't need an initial value, right?
But like, isn't answer only used within the scope of the if statement?
No, the scope of answer is the entire function. Right?
Oh, right.
Okay, so it is the case if the if statement doesn't execute, answer will never get assigned. But like that's exactly what I was just spending all of this time talking about, right? That I set current maximum coverage to a value which necessitates that if statement will trigger at least once, thus setting answer. Right? Was this right? Oh yeah, it gave me May. So let's just try to give something else. Let's say that August, which is the best month to have a birthday, has what, 3 people in it? August, oh, I need another dictionary. Jeez. 7th. Me. Someone famous. Someone else who's famouser. Right? Oh, that was wrong. All the days. No, this is right. So my mind is wrong and this is correct. Okay, anyways, you can play around with this. Let's just check out what the... So that was part 1 of this question, which was fairly... This was already a long answer question on your final. And it was what? Like that. This really isn't that sophisticated of a piece of code, right? It basically requires you know how to write a loop and understand how dictionaries work. It's a very fair question. The second part of this question asks that you basically do the inversion, which we've done like 3 times already in this class. So why don't you guys try to do the second part of this question? They're making it even easier, actually, because they're basically saying, invert this dictionary and assume the keys are unique. So you don't even have to worry about multiple keys hitting multiple values. You really just have to go through here and swap everything. All right, so give that a try. You got any questions before I kick you guys out of here? Okay, why don't you guys go trick or treat? Okay. Steal some candy from some sick kids.